Okay, firstly, you're all very welcome. My name is Katie O'Neill and I'm the Marketing Manager at the College of Engineering and Architecture in UCD, and I am your host for today. Today, we are very lucky that we've been joined by Head of School, Professor Ken Stanton. In addition to that, we have a 2017 graduate, Conor Dempsey, and a current student, Holmes, both of whom will share their experiences with you. So without further delay, I would like to introduce you to Head of School, Professor Ken Stanton.
Thanks very much, Katie, and hello to all of the attendees. It's wonderful to have you all with us today. As Katie said, my name is Ken Stanton. I'm currently the head of school for the School of Mechanical and Materials Engineering. Of the 5 schools of engineering, we are the largest one, and we account for roughly 50% of all of the taught students at UCD engineering. We have over 100 staff in the school, of which 32 at present are academic members of staff. Our research funding awarded over the last 5 years is in excess of 30 million euro. And we have programs across a variety of subjects and disciplines, which I'll explain in a little while, that are accredited to international standards. So, for example, most of our ME programs are accredited by Engineers Ireland, who then have international agreements to ensure that our graduates' qualifications are recognized worldwide. We have an enviable 96% of our students are employed very soon after graduation. And all of our ME programs have an internship. And from the students doing internships, roughly 70% of them will get a job offer from their host company, and roughly 50% of them will take it. The others going on to do other things. We are home to some very prestigious laboratories, including a Science Foundation Ireland IFORM Centre for Advanced Manufacturing, which is a national laboratory and has collaborators from around Ireland, of course, but also we have within that a Centre for Doctoral Training that's in collaboration with some universities in the UK, including Sheffield and Leeds. We're also home to the Centre for Micro Nano Manufacturing Technology, the MNMT lab, and that's run by Professor Fengzhou Fang, who is an SFI research professor with a very, very large group and focuses on precision manufacturing. They're just a couple of examples, and our activities, of course, are much wider than that. Within the school, we separate out our programs and our activities into 4 subjects. The first of these, of course, is mechanical engineering, and we have 2 programs in mechanical engineering, and they are a 4-year Bachelor of Engineering, and then our ME, or our Masters of Engineering, which is a 2-year program designed for people who already have a suitable undergraduate qualification. So all of these ME programs have an internship. The other subject, next subject, is material science and engineering, and we have 2 programs in that. One again is an ME in material science and engineering, and for example, one of our guest speakers today, one of our former graduates, Conor Dempsey, is a graduate of that program. And then we have a 1-year MNGSC in material science and engineering as well. There's no internship with that, but it's more like a 1-year conversion course for people who are interested in materials. The next major subject in the school is systems engineering. And in fact, by numbers of students taking programs, this would actually be the largest. So we have a 1-year MNGSC in engineering management. We have our 2-year ME engineering with business. This program ensures that people do have suitable engineering education, but then augments that with some business subjects and engineering management subjects. And for example, Holmes, who's again one of our guests today, is a current student of that program. We then also have a master's in engineering management, but this is for experienced engineers who are generally still in full-time work, and that's a 2-year part-time program. The next major subject we have is biomedical engineering. And again, we have a 4-year undergraduate BE program, and then we have a 2-year ME. The area of biomedical engineering is sort of quite diverse around the world and how that's approached. And I think it's fair to say that we take a very device-oriented approach at UCD. In other words, we focus on biomedical devices. And that is because Ireland is one of the major global manufacturing centers for biomedical devices. And again, Conor, who's here, works for a major multinational called the Synthes, who manufacture orthopedic, predominantly metallic orthopedic prostheses. Of course, we then have, the BE and the ME in biomedical engineering. And then finally, we have energy engineering. And so for that, we have our ME in energy systems. That is very much in collaboration with our colleagues in the School of Electrical and Electronic Engineering, because it has to do with all elements of energy usage and power usage from national grid level right down to management of energy, for example, within homes and energy efficiency. So our major research themes then arise from what I've just described, and those would be design and manufacturing. Manufacturing is a real growth area, not only, for example, in the biomedical device sector, but I've had recent conversations with Intel, who have a global manufacturing base here, roughly 20 kilometers from the university. And they are in the process of establishing a major new fabrication facility for 7 nanometer feature chips. And they will be employing roughly 1,600 new people within the next year and a half. And we hope to be very much a part of that recruitment drive. We then have energy as a major research theme. And again, it's within our school, it is predominantly to do with things like heating and cooling in homes, buildings, energy management. I guess that summarizes also things like thermal fluids and combustion engines and domestic heating, that kind of thing. Then we have materials science as a major research theme. Examples of major projects in that would be, for example, I was involved in developing a coating that is used on the European Space Agency Solar Orbiter mission that's currently on its way to the sun, launched last year. Colleagues are very interested in metal additive manufacturing or 3D printing with metal, especially for things like orthopedic devices. And again, Conor is involved in that activity. And then finally, we have a lot of activity in biomedical engineering, and that runs everything from tissue engineering type interventions through to things like microneedle patches and novel medical devices. Of course, biomedical engineering then pulls in elements of material science and pulls in elements of design and manufacturing. And so there's good synergy between all of those research themes. So that's where I'll conclude for now. I'll hand back over to Katie to introduce the next speaker, and I'll be available for questions at the end. Thank you all very much.
Thanks, Ken. I think it was great to get that excellent overview of the school, which is very large and covers a large amount of areas, both in the masters that it offers and then the research areas that the school and academics are involved in. So I would like to introduce Conor Dempsey. He is a 2017 graduate of the ME in Materials Science and Engineering program. Thanks, Conor.
Thanks, Katie, and thanks, Ken, for the introduction. Let me just share my screen. Hi, everyone. So as Ken and Katie said, my name is Conor Dempsey. I graduated in 2017 from the Material Science and Engineering Master's program. Since then, I've worked for Thesis in an orthopedic company, which is part of Johnson & Johnson. So I'm going to take you on a kind of a whistle-stop tour of my career, my college to date, and just kind of highlight the different important points that led me to my current path. So we'll start off with my undergrad. I did a BSc in mechanical engineering in UCD. I started that in 2012. I originally wanted to be a doctor, probably like half people who end up in engineering. They have some interest in medicine. And then in transition year, we had a talk from Engineers Ireland. And it was so fascinating, like the stuff that I wasn't sure that engineers were involved in, and the kind of cutting edge work that they do, which really appealed to me, as well as still wanting to be involved in, stuff that helps people, such as the biomedical industry, aerospace, kind of advancing humanity, I suppose. And then everyone is interested in renewables and the longevity of the planet and all that fun stuff. So those are my three kind of main interests into starting engineering. So I wasn't overly sure of exactly which path I wanted to go down, but first year was kind of a general engineering stream. I picked the modules based off those three things that I wanted to go into. So I picked anything in energy engineering, anything to do with space, the conceptual physics, the astrophysics modules, and then biomedical engineering. I loved the the anatomy modules, biomaterials, design of materials was another good one in second year that kind of touch on all these spaces. So I purposely chose those just to try and touch off everything and try and define where I wanted to do my master's. In the summer of third year, I got the opportunity to do a manufacturing internship in China through a crowd called ISD, who have great links with UCD. Just prior to this, I actually chose the ME Material Science and Engineering Masters because I wanted a degree that could be in any industry. The kind of 3 years hadn't narrowed it down enough for me to pick any one of the other things like energy engineering. I had tried the mechanical modules and didn't like a lot of them. I was allergic to mechanics of fluids, and computational continuum mechanics didn't appeal to me. But I really liked the materials modules. I liked how kind of broad they were, at the same time being very specific. And I'll touch on that a little bit later on as well. So in that summer, I did an internship as a manufacturing engineer, a manufacturing design engineer was specifically what I was doing. And with this, I had a lot of CAD work to do. So I was designing fixtures to basically help their assembly process. They assembled everything by hand using associates. So my job was to basically make a fixture that they didn't have to think about where anything went, and it just slotted into place to speed it up. As well as this, I got to kind of introduce the CAD package that we had used in manufacturing design in second year college, or third year college, to that entire company. So it was quite a lot of responsibility, but I felt I was well prepared with the things that I did. So then I came back to start the master's. As I said, I chose it because it was really aligned with what I was interested in. It's applicable anywhere, biomedical, in the space sector, and in the energy sector. They're all kind of limited by their material applications. I also really enjoyed the intro modules, so the design of materials module, the material science engineering 1 and material science engineering 2. I didn't enjoy, as I said, the mechanical core modules, so fluids, CCM. There was also a lot of flexibility given with the option modules, because it's so broad. Like the core modules are obviously the kind of the generic material science engineering modules, but you could pick, biomaterials. You could go into more electronic focused as well if you're interested in that. You could keep the mechanical core modules if you wanted to. It had a lot of flexibility, and that really appealed to me. And as well as that, the flexibility of the future career, I could kind of get into anything if I wanted to. This led me to my internship, as Ken said, is offered in the first year of the master's program, and I would highly, highly encourage anyone to do it. So in 2016, I had a co-op placement in Diffuse Synthase within the materials development group, as it was called then. At the time, there was about 20 people in it, and I was on the metals and coatings team. They were kind of grouped together at that stage. In this, I was involved in the process validation of the automatic hydroxyapatite coatings line. Hydroxyapatite is it's the white coating on the hip implant that you see on the bottom right of that screen. I was also involved in the machine validation side, so qualifying the machine to make sure it can, it can do what you ask of it. The process validation is kind of the outputs are where you want them to be, the right material properties, which is really the bread and butter of what we're kind of doing, So I was involved in machine validation as well. So I got to see both sides of it with an automatic porous coating application line. So the top part is the porous, that's called pour coat. That line was to automatically apply it where the process has been manual for the last few decades. I had a lot of exposure to the biomaterials and the coating side of it. I had some exposure to 3D, and I was also heavily involved in lab testing in the materials lab that's here on site. I then took a master's thesis away, which is supervised by Ken, completing the project on improving the properties of the hydroxyapatite coatings. To kind of give everyone an idea of what I'm talking about here with coatings, there's two generic kind of sets of implants. There's cemented implants and cementless implants. So the vast majority of people who require hip replacements or knee replacements require it as a result of osteoarthritis, so a kind of a breakdown of the joint. In some cases, the patients will have osteoporosis. That means they can't fully grow the bone themselves. In these cases, they need bone cement to fix the implant and make sure it's stable long term. In kind of younger patients or healthier patients, cementless is preferred. So it uses a porous coating that mimics bone and basically encourage bone growth into the implant, so the patient can kind of ensure long-term stability themselves. So that's kind of the preferred method. It massively improves the patient outcome, and you don't have to push. You don't have to rely on bone cement, which it is a cement at the end of the day. It's exothermic. It heats up as it sets. And if you're heating up your body, your body heats up as a kind of reaction to viruses to try and kill off organic cells. So it's not an ideal situation to have to require the cement, but oftentimes it's a last resort. It's the only way that it will keep the implant stable. So the market is more and more moving towards this cementless implants, and that's really what the materials development group was kind of built on, developing these cementless implants, as well as there's a lot of other areas around the material properties of the metal itself, the base metal, and improving the projects on site with that. So after I finished my internship, my thesis, I went back to work in the Pew Centres. I was given a job straight after college. I finished the ME in June. I was allowed 3 months to travel South America, fulfill my dreams from June to August. And then I started in the metal 3D printing team in September. I was initially involved in speccing and purchasing equipment for a 3D development line that we've set up in Cork. So making sure we're buying the right equipment, getting the quotes, going to the vendors, even like visiting the vendors in person to make sure that they're giving us the right equipment. I was also trained on running the 3D printers and the 3D software. I was also leading the characterization of the materials and the lab validations. And all of that was kind of as a result of my materials background, and as well as that, my internship where I got exposure to that. I was leading the build file preparation for the project for producing a new tibial tray. Again, this is kind of on my background with the software through the core mechanical modules and through my internship in China. This led to me then being responsible for the process qualification of the 3D printing of the tibial tray in the last number of years. And with all of that, they gave me an opportunity to go on a black belt training for Six Sigma, which is it's a problem-solving methodology, but it's brilliant for process development and setting a process up for success. So all of this was kind of as a result of the background that I had. I then got promoted at the end of last year, and I'm now a senior materials engineer. So what I now do is I lead the validation for the tuned cementless tibial tray, which is the project that I've been on for the last 4 years at this stage. I apply the Black Belt Six Sigma methodology daily in trying to do process improvements and problem solving. I'm the expert on the 3D printing software. I'm the subject matter expert for 3D printing. So if there's any problems with the machines or the products, they come to me, and I kind of give them advice or try to problem solve there. I'm the technical lead for the stability of the production process. So again, if the machines are down, if there's questions over the product, I have to provide my input. And I'm also leading the co-op program for the Cork site. So looking after all the interns, making sure all the managers who require interns are getting them, and making sure the interns are placed in the right place. So I'm still heavily involved, and I have a good link with UCD as well as the other colleges around Ireland to fulfill that requirement, basically. So why pick the ME Material Science and Engineering? So at a base level, it gives you an understanding of material properties, and everything we do is governed by material properties. It's why your building stands up. It's why the computer chip in your laptop runs as well as it does. It's all down to how that material functions. A lot of engineering applications are limited by current materials. So, wind turbines can only get so big because they're the length of that blade. The materials can only be so strong. Solar panels are only so efficient because of the materials they're using. Semiconductors are, govern chips and how fast they can run and how much data they can hold. So a lot of things are limited by materials. A lot of industries are limited by them, and a lot of problems are solved by improving those outcomes. It gives a very specialist knowledge. Like, you think if you're just finding out about materials and why they function, it's quite specialist when you think about it in the context of, say, the wider mechanical branch. But the applications are endless. You can go into anything. And with that, there's this massive employability, particularly in Ireland. As Ken was saying, there's so many biomedical companies in Ireland, and there's so many medical device companies. We have, I think, 9 out of 10 biggest companies are based in Ireland, and they have huge centres here. Like the Cork, the Pew site is considered the flagship site. So a lot of the new products we put through here. And then all the skills that you pick up, you might pick them up in context of whatever industry you're in. They're hugely transferable. A lot of other industries are having the same problems and need to have the same solutions. Just to give you a quick overview on where I am now. So I work in the material surface technology. So in my internship, it was called the materials development team. Materials development was the name of the group. There was about 20 people in it, and it was really split into, it was like metals and coatings. It had cleaning, and then I think foundry was the other one. So quite broad groups. It's now over 100 people. It's much more global as a function, and it also has an end-to-end function. It goes all the way from the sourcing of the raw materials right through to the cleaning and sterilization of the product as it goes out the door, and everything in between. So, we go to forging, bar stock, the foundry. We look at the coatings, the special processes there. So it's kind of expanded as well, and I've gotten to see it all the way from the start to now. And it's kind of a great journey, and it's all focused on the material side of it and proving the value of this knowledge to the business. Like, our team is global, as I said, it's about 100 people. It's really highly educated. There's a great split of people across the world, and it's probably one of the largest gatherings of, I suppose, professional material scientists in the world. We haven't found any bigger yet. I don't know, Ken, if you know if that's if that might have changed in the last few years, but yeah, over 100 material scientists are in our group. Just the kind of main focus of this group is there's these 3 horizons. So the technologies that defend and extend core business, to build emerging business growth and creating future opportunities. So defending core business is the stuff that we're already doing. As I said, hydroxyapatite, the project that I was working on, that's kind of considered one of them. We have emerging growth, so the 3D printing, which I'm involved with, as well as a host of other things. And then there's future opportunities such as, bioprinting, anti-infective coatings. These are all the kind of stuff that we're involved with to try and create new products and better patient outcomes, as well as, better outcomes for the business as a whole. So that's a whistle-stop tour. I suppose the questions are at the end. So thanks very much for letting me speak.
Conor, that was absolutely wonderful. And in the last 4 years since your graduation, you seem to have packed a huge amount in, had an incredibly exciting and progressive career to date. So thank you so much for sharing your experiences so far. We're also very lucky today to be joined by Ciara Holmes. Ciara is a current student with us. She's in her second year of the Masters of Engineering with Business. I can see from the background that she is actually currently in UCD right now. So I think getting the perspective from someone who is currently studying a Masters in this school will be very interesting. Thanks a million, Ciara.
Thanks. So as I've been introduced, my name is Ciara Holmes, and I'm in my final year here in UCD. I did my undergraduate here as well in mechanical engineering, and I'm now in the master's program mechanical engineering with business. So I basically chose my master's degree based on, by the time I got to the end of my undergraduate, I knew that I didn't want to be a design engineer. That kind of didn't interest me. And I was interested in getting a better understanding of how engineering companies work as a whole from like an operations and strategy perspective, I suppose. And the business masters gives you a really nice mix of technical and management modules. So you have that greater view of the company as a whole. It's also fully accredited, as Professor Stanton was saying earlier, it's fully accredited engineering degree by Engineers Ireland, and it's internationally recognised. So you have that choice at the end of it, if you want to stay in a purely engineering function role, or if you wanted to move more towards management, operations, or even totally away from engineering into like management consultancy. Some people go that way as well. So I suppose I'll start off by talking about academics and kind of what it's like just being a student here. On the master's program, the classes are pretty small. I think most of my classes was probably max 40 or 50 people. So you get to know your classmates quite well, and you get to know your lecturers and the teaching staff, which is really nice as well. Group work is really highly emphasized on the program. So I'd say the majority of my modules, I had at least one group project. And that it's challenging, but it's such a good way to build, like your communication skills and other soft skills. And you meet loads of people through it as well. You make friends, and having friends always makes your homework a bit easier. So that's always a positive. There are a couple of rooms in the engineering building that the mechanical master students tend to work in, and I've always found it really helpful for me to come in and do my work in there, because if you have any questions or anything, there's always a bit of support around and a bit of morale as well. Since before COVID, there would have probably been a much greater emphasis on final exams as a method of assessment, but since COVID, and since a lot of the teaching activities have gone online, that's changed completely, and there's been a lot more continuous assessment. So I imagine some of that will probably carry on into the future, but I think it's positive. The next thing I would say is, I suppose I'll talk through a couple of the modules that I took, just for an example. We did thermodynamics, we did material science, and we did manufacturing class. They would have been some of my technical option modules. And then from the business, or it's probably more accurately described as engineering management, because we share a lot of classes with the engineering management master students. We took operations management, management and organizational behavior, decision support systems was a really interesting class. And then we did a few more kind of core business modules like entrepreneurship and marketing. Yeah, that's pretty much it. So then on top of the classes, the next thing then is the internship. It's a really positive experience. I did mine for about 7 months, I think it was. It was from last June to December. So you have so much choice of where to go, and so many options to make it suit your career goals. UCD makes it really easy for you because they have an online platform where you can browse a lot of job options and apply through the platform. But you also have the freedom, if you want, to go outside of that and find your own internship. And once you get it signed off by someone in the college, you can do that too, which is brilliant. I have a friend who went to Switzerland to a startup in Zurich and had the time of his life, and he's going back there after graduation. I myself went to a wind farm management company here in Dublin called CGN Europe Energy. It was really good experience because it was a small company. It was part of a larger company, but the Irish branch had just been set up in the last couple of years. So a team of maybe 15 people. The benefits of being in a small team, you get to see all the other business functions working and not just your own. So I got such good experience as a business master's student because I got an eye into like what the finance team are doing and like how strategic decisions are being made, things like keeping up with contracts, dealing with contractors, so many different parts of the business, whereas in a bigger company you might just get put into one section, which was a positive. So I was on the operations team and got to visit site as well. So I think one of the positives of the internship is you get to see whether you enjoy working in a small company or a big company, whether you enjoy office work, site work, remote work, whatever it might be. You just get to test it out and see what works for you and get professional experience in the area you might want to go into as well. You can see like what the industry is looking for. It's kind of difficult to know until you're almost there. So that's really good. And as Professor Stanton said, the majority of people come out of their internship with a job offer, which is really positive as well. And the next part of the master's program is the thesis. So normally you're given a list of topics, your class is given a list of topics and you can choose from that list. But same as with the internship, if you have an idea of your own, the staff are quite happy to support you. If there's someone on the staff that is happy to supervise you, you have a bit of freedom with that as well. So it's another way to kind of tailor your degree, to gain experience, maybe new skills in an area that you want to work in. I'm doing my thesis currently on analytics of pricing and promotions for a multinational e-commerce company, because I wanted to improve my coding skills and understand a bit more about business strategy. But there's such a wide range of different thesis topics, so you can really tailor to your interest, which is really positive. The next thing then, something I'd be a huge advocate for is getting involved in extracurriculars. So the whole way through my time at UCD, I've been involved in various different extracurricular activities, and there are plenty of them under the engineering umbrella in the school. So there's a chapter of Engineering World Health. Here, there's a Formula student team who build a race car, and a few of my friends have had great experience in that, where you can use your engineering skills and have a bit of fun with it as well. Of course, the Engineering Society. I was on the Women Plus in STEM Society, and I'm currently a member of the Engineering Graduate Association. In the college then, you have a lot of, there's a lot of support to be found around the college whenever you need it. We'll say we have a lovely student advisor. I was talking to her recently, she helped me out with something. So don't be afraid to stick your hand up and ask for help, because there's people there ready to answer your questions if you need them. Your lecturers and supervisor are always there. There's a dedicated career representative in the career office who's for the College of Engineering and Architecture, and they're fantastic for career advice. And if you have any extra needs or need extenuating circumstances, I've always found the college to be very accommodating. And then, of course, there's so many career opportunities with, whether it's a mechanical engineering degree or as mine is like mech with business. There's so many career opportunities. I have friends going into renewable energy, manufacturing environments, even, as I said, management consultancy, analytics, or even into design engineering, of course, as well. So I myself currently, unlike the rest of my class, I don't have a job currently. Most people would have graduated with a job sorted. I learned from my internship that I don't enjoy remote work, so I decided to put off my job search for a little while. But hopefully I'll be looking forward to trying to find an opportunity in a operational role, perhaps in manufacturing and in a multinational eventually. So yeah, that's pretty much it for me, I'd say. If you have any questions, then I'll answer them at the end.
Kira, thank you so much for taking the time to share your experience with us. Really interesting to hear, particularly as you are still a current student, which is great. We have a few questions that have come in. This question could be for Conor or Kira, so either of you can jump in on this, or maybe both of you. You mentioned the flexibility in terms of the number of modules that you have. Someone's wondering, how did you actually choose the modules, and did you get any support? I suppose it's more if you're not certain which modules are the right ones for you. These are not the core ones, obviously. How did you go about choosing and knowing which were the right ones?
Do you want to go first there, Kira? You're kind of more recent in it.
I suppose. I didn't have a whole pile of options. I think I just my technical modules in fourth year. I was able to choose. I just chose them based on interest, and I knew pretty much straight away which ones I wanted to do and didn't want to do. But I'd say you could talk to anybody on the academic staff to get more information about the modules, and if you know what you want to get into when you graduate, then pretty much anybody on the staff could probably direct you as to which modules would be helpful and beneficial to you.
Do you have anything to add there, Conor?
Yeah, like there wasn't, from my memory, I think there was like 4 core modules and then 12 modules total. I don't know if it's changed since or if my memory is a bit foggy. Again, you might correct me if I'm wrong. But I got to pick them based off my interest. There were some decisions that we made, there was some ones that I would have liked to do, but they clashed at the same time as something that I would prefer to do. It was really based on my interest. Once I did my internship as well, I kind of knew I wanted to go back. I really like the work here, and I like the group that I'm in. So I was kind of interested in going towards that space, while also keeping stuff that I was interested in. So I did keep, there was a energy and climate change module that kind of stood out as one of my favorite modules. And that's just based off what I was interested in, as well as that, trying to keep the useful, like directly useful modules, such as biomaterials. And, I think there's like a lab method module. There's processing modules as well that I took as well, just to, it was all quite interesting to me.
Very good. Conor, someone asking, they know you did your internship as part of your master's, but how did you actually secure your summer internship, which was probably more, it wasn't part of your master's, it was something you may have initiated yourself. They're just wondering about the internship you secured in China.
Yeah, I applied directly through a group called IESTA. It's the International Association for the Exchange of Students for Technical Education, I think it is. And it's a worldwide organization. They kind of companies all over the place, and it's based off, if I go to China, then Chinese students come to Ireland, or I'll go to China, someone from China goes to Germany, and some German student comes to Ireland, kind of thing. So it's a really kind of collaborative internship program that I got involved with, that I applied to directly because a friend of mine who was in electrical engineering, she had done hers in Switzerland, I think the year before, in second year college. So it's kind of more open to second, third year college than say first year college. I just applied to them and said I want to kind of go as far away as possible. Brazil or China or Kazakhstan, I think are the 3 I applied to, and I got the one in China. So it's just an interview process, like cover letter, CV, interview, and pick. So I'd encourage anyone to do that one.
And just on the internship theme, someone is asking, how easy was it for both of you to secure your internships when you were going for it as part of your master's program? Kira, we go to you first.
Yeah, sure. So the online system, you're with all the companies submit their internships to UCD, and UCD, presents them to you through the system, and you're encouraged to apply for between 5 and 10, I think, internships. If you applied for any more, it would be far too much work. And then if you get invited to interview based on your application, most people will get a couple of interviews, and it's a fairly easy process because it's all kind of organized for you almost. I actually had the unfortunate experience of going through the whole process and then losing my internship due to COVID. It was cancelled, but UCD helped me find another one very quickly. So they're very supportive in the internships office.
It's good to hear, Kira.
Yeah, it was very much the same. They come out with there's a list of jobs you can apply to, and you kind of put them in order of priority, which ones you actually kind of want, and tailor your CV and cover letter to that company. So I got the first one I interviewed for, luckily enough. Didn't have to go through too many of them. Yeah.
Excellent. I think it's also worth mentioning the college does have 2 dedicated internship managers, Eileen and Fanula. So there is a lot of support available for students to engage with, as Kira and Conor have both mentioned. Ken, someone's asking, is it possible in a master's to apply for recognition of prior learning if they think they've already covered something at a bachelor's degree?
As far as I know, it is, yes. The university has a recently revised RPL policy that became operational, I think, from last September. So there are limits on the amount of RPL that can't be claimed. But certainly for people who have potentially done a 4-year bachelor's elsewhere, there is provision to get RPL for some of the ME content.
Thanks, Ken. And you're right, there is an online application for that, and Laura might actually pop the link up there. And probably following on from this, I'm not sure if it's the same person, asking specifically around the ME Energy Systems Engineering Programme, which is an ME. It is mentioned that it can be completed in a year, or I know also sometimes a year and a half or 2 years. So what is the procedure to see if you can complete it in a shorter time frame than the 2 years, Ken?
I would say that the best procedure in that case is actually to have a dialogue with the program director. So that's currently David Timoney, with some support from James O'Donnell. And so we encourage one-to-one contact and dialogue with our academic staff where possible. And so David Timoney, the program director, would be the best person to contact about that, and he can look at the person's specific background and understand whether, and make a judgment on whether that would be possible.
Thanks, Ken. I know the best way to get in contact with David would be to direct that email through Michelle Matthews, who is our admissions manager. So Laura might be kind enough just to pop in her email address. You can email her directly, and she will liaise directly with David on your behalf around that particular query. We just have time for one final question, which I'll direct to Laura, if you don't mind. Somebody is asking, and I think they're an international student, specifically around the career supports that they could engage with in terms of looking to pursue a career straight after their master's completion.
Yeah, sure. So we do have a dedicated career support team available to UCD students. Kira mentioned that we do have a specific college liaison in the careers office who'd be very familiar with the circumstances around engineering students. But they do a lot of supports. They do CV clinics and workshops for students to work on their profile. You can get a one-to-one meeting with them to discuss your options and maybe what you're interested in. They do psychometric testing. They do lunchtime seminars, and they invite companies on campus to do seminars as well for students. A couple of times a year they do career fairs. So one in particular is a more general fair that anyone can go to, and there's plenty of companies there at that one. And then one is a STEM fair as well. So that would be of particular interest to our engineering students. A lot of engineering type companies at that particular fair. And they do the careers jobs portal that Kira mentioned for the internships, but they do one, a more general one where companies would post jobs there that students can apply for. And then also we would have through the Engineering Graduates Association, there'd be mock interviews available to students on the ME programs as well. So there's a lot of supports there, and most students find that they're very, very beneficial as well.
Thanks, Laura. I'm afraid that's all we've got time for today. All that's left for me to say is to say a very sincere thanks to the Head of School, Professor Ken Stanton, our alumna, Conor Dempsey, and our current student, Ciara Holmes. Thank you so much for sharing your experiences. It was excellent to hear. And also my colleague, Laura Egan O'Brien. Thank you all. Take care.